Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we're going to be looking at how to create a Python application that has a graphical user interface. Now this is something that you would do if you wanted to write an application that you're going to give to a non-technical user, because non-technical users are very used to using applications on Mac or Windows and even Linux that have graphical user interfaces. So if you can make your Python application look like one of those apps, then they'll understand how to use it. So we're going to use the tkinter library, which comes with the standard Python install, and have a look at how to use that. Now I've created a couple of files here that have got cover what we're going to cover today. I've got one which hasn't got the answers in it, so I suggest that's the one that you work with. And I've got one which has got all the answers, so that's just a reference that you can look up later if you miss anything during the video. Now we store these files in our GitHub repository, and this has got all the session summaries from all the sessions that we've had when we were at River City Labs or the TC Burn building, when we were at the State Library of Queensland, and when we were at Red Hat. At the moment we're doing them out of online, and so you look in the online folder to get the files that you want. This is Meetup 83, so the two files we've got here are tkinter Keyring and tkinter Keyring with answers. So if you go in to look at any one of those files, you can see the file itself, and to download it you click on the raw, and that gives you the URL for just the file and none of the extraneous stuff. Now when I click on that in my browser, it comes up, it actually shows me the file. So I have to save that page as, and I pick a place on my in my home directory where I want to save that. Now I'm going to save that, so Python8 is my home folder. I'm going to be using PyCharm, and PyCharm likes to store its projects in PyCharm projects. So let's create a folder in there. You can store it anywhere that you've got read and write access to. So let's call it Beginners Python and Machine Learning dash tkinter, and we'll create. So I've created a folder. The file name is fine, Meetup 083 Tim tkinter Keyring, and it's a Python script. So that means it'll just put a .py on the end. So we'll save that. Okay, I'll go back and I'll grab the one with answers as well. So I'm listening on the Slack channel, Learning to Code, and I'll also be following the YouTube chat. So if you've got any questions, feel free to ask me and we'll go over. This is supposed to be beginners Python, so it's you know, any sort of questions are valid questions. If I don't get questions, I'll just assume that you know what I'm talking about, and I'll probably just keep making it harder and harder. So if it's starting to get over your head, then start asking questions, even if the question is, I don't understand. Okay, so this is the one with answers, the raw one for that, and so we'll save that. The other thing we're looking at today is Keyring. Now Keyring is a way of storing passwords when you've got a project, because sometimes you've got a program that's got to do something like connect to a database or connect to an email server, and those things require passwords. But you don't want to be storing those passwords just in a text file in your program, or even hard coding them into your code, because anyone can look at your code and see what you've written. So Keyring is a way of solving that problem. Okay, so we've created that. We've got those two files. Now I'm going to fire up PyCharm, which I've got here. So It says PyCharm Edu is the one that I'm running. It's actually the Community Edition, PyCharm Community Edition. I've got a plugin installed which is called EduTools, but we won't be using any of that today. So just the straight PyCharm Community Edition is fine for what you need. You could do all these exercises today with just a text editor, but it is going to be a little bit harder for you to do that. Now I'm going to click on Open here, and I'm going to open the folder that we've just created. So let me know how many of you are using PyCharm, or if you tell me what other IDE you are using, whether you're using Spider or you're going to try to do it from the command line. This one here. But I'll be explaining how to use PyCharm, but I can answer other questions if you've got them. Right. You saw down here it said it's set up for Python 2.7. 2.7 is 2.7 is a very old Python, so really we're using 3 for this. Peter says he's using VS Code. Now I saw an excellent presentation in the Brisbane Python users group on how to use VS Code, and I learned a few things from that. And I think that was done by Peter. So yeah, Peter, if you've got any questions, just ask Peter. Okay. All right, so we need to set up a virtual environment. You see it's saying down here, Python 2.7 has been configured as the project interpreter. If you look right at the bottom of the screen, if I pull up the Python console, it's saying Python 2.7. So that's all wrong. We need to use Python 3. So on Mac, I'm going to go into PyCharm Preferences. If you're on Windows, you want to go into PyCharm Settings, which I think is in the File menu. And what we're going to do is we're going to set up a virtual environment. It's a very simple virtual environment. So even if you're using VS Code, you should be able to set up one that works for you. So you go down to your project in Settings or Preferences, and we're going to click on Python Interpreter, and that's where we're going to tell PyCharm which Python interpreter we're going to use. We're not going to use Python 2.7. We're going to set up a new one. So we click on Show All, and just tell me if I'm going too fast here. Because this is something you'll do on every one of your PyCharm projects. So it's good to go through these steps and work out what you're doing. All right, now these are virtual environments I've set up before, but I'm going to set up a brand new one. And I've selected virtual environment, virtual env environment. And that's because I've got a standard Python install. Actually, my Python install I'm using is from Mac ports. So it's a little bit different to the one that you'd get from python.org. The one from python.org is actually a little bit easier to use. But so we set up a new environment, and I'm going to call it just venv. If you're using Anaconda, then make sure you select Conda environment. And so the questions are slightly different. You can choose here what version of Python you're going to use, which one's been selected with your Anaconda. It's come with your Anaconda. And it's where it's going to save that environment. And you have to choose your Conda executable. So Conda executable is a program called Conda that you've got on your computer. Don't use either of these two. We're just going to use virtual env or Conda. If you're doing it from the command line, I'll show you the commands in a minute to do that. Okay, now here you choose your Python that you're going to run. Now mine, because it's in Mac ports, it's stored in opt local library frameworks, python.framework versions 3.9 bin Python 3.9. Okay, Peter said he's got the conda command from the command line working, so that's great. Now, because I've used Mac ports, I have to inherit global site packages, and if you have trouble getting this graphical user interface stuff to work, you might have to come back and click this one as well. So normally when I'm setting up these virtual environments, I don't need to click this, but because I'm using tkinter, it's the way it's installed on my computer. I have to click that checkbox. All right, and I'll click OK. So now it's going to go off and create that. And you can see the folder's being created up here because I put it in the same folder as my project folder, so that I can just keep track of it. Okay, so Leonardo said he's using VS Code. So if you've got any questions, Leonardo, about how to get VS Code to do this, just type them into Slack, and someone will try to help. You can, let's see, so that's selected, so I'm going to click OK on that one. And you see this is a very small environment. These are the things that are currently installed. And I've got, don't worry about Python, you don't need that, but because it's one of my system site packages, it's showing on my install here. But you'll probably have pip and setup tools and hopefully tkinter. So I'll click OK. Right, now if you look in our file, which is tkinter Keyring, that's the one you downloaded, I've got some instructions here on how to create a virtual environment. So if you are typing it, here we go, create a virtual environment. If you're on Windows, you can just type, this is Windows without Anaconda. You type Python-m, then system, and you might not need -- system site packages. Maybe just try it first with that first bit, and then if that doesn't work, then try it again with this. So this venv here, that's the module that now comes with Python that creates virtual environments for us, and this venv is what we're going to call the folder that's going to have the virtual environment in it. Conda is the command for Conda. It creates them in its own directory, so if you type this from the command line. So if you're running PyCharm, you can do the same thing. You would do those commands from the terminal tab. So I'll click on the terminal tab down here, and you could type them in there to create it. But you can see at the beginning here in the prompt, in parentheses, it says venv, which means mine's already created. But if you're in VS Code, you'll probably have a terminal prompt that you can, a terminal place that you can type in these commands, and so you choose one of these commands here to type in to create your virtual environment, and then you need to activate it. I'm not sure exactly how VS Code activates them. You can activate them on the command line here by typing that in, or you can, sometimes the IDE will activate it for you, as my PyCharm has done. Now we've got our virtual environment. We've got one package we need to install, which is Keyring. So you could just type pip install Keyring when you're in your virtual environment down here in your command line. But if you're using PyCharm, PyCharm's got a really neat feature. If you create a file in this same folder called requirements.txt, and this is a Python standard name, and you put in that file the name of anything you want installed. So I'm just going to say I want Keyring installed, and it'll say the package requirement Keyring is not satisfied. Do you want it installed? And I'll say yes, please install that requirement. There's also this blue line here. I normally click on ignore extension for that. Okay, it says down here, package successfully installed Keyring. So now I can use Keyring in my code. Let me know how people are going in getting these virtual environments up and running. Otherwise, I'm just going to keep moving on. So that's really the first task, is just getting your virtual environment set up. And the reason you do virtual environments is to, because you can be working on several Python projects. And if you install something, if they're all working on the same environment, like your system environment, when you install a library that works for one, it can upset some of your other projects. So by isolating into these virtual environments, you can say, this library that I'm installing, I only want it to affect this particular project. And it also means that when you then give your project to someone else, you can say, if you want to run it, these are the only libraries you need. Now, Anaconda has a habit of just giving you a whole bunch of libraries just for free, which makes it harder to then know exactly which ones are needed when you hand it over to someone else. And so you'll often just say, you need Anaconda. Okay, so this .py file is our Python script. Now, all this stuff at the top here is optional. We've got a couple of comments up here. This one's called a shebang to tell it that it was using Python 3. That's not really needed in Windows, but it works well in Mac and Linux. The second one is tells you what character encoding. UTF-8 is the default, so you don't really need that. But this makes it compatible with particular editors that also read that second line to find out what your character encoding is. So Python say, yeah, it's fine to put it in there and it won't affect the Python code. Then I've gone these triple double quotes to put in my doc string, which is basically a help message for anyone who's reading the file. So it's a string, it's got multi-lines in it, and I've also put an R out the front because in my string I've got a few of these backslashes, and so if you don't put an R in the front, then the backslashes are actually interpreted as a special character, but the R just means just a raw string, and so I put that there so that these backslashes don't affect anything. Okay, so that's all optional, that stuff at the top. Now we've got our import commands. Our imports are the standard libraries and third-party libraries that we're going to use. So all of them are standard libraries except for Keyring, which is a third party, which is why we had to install it separately. Okay, Peter said he had to manually select the new virtual environment in VS Code. So if you could tell us, Peter, where you select that, that would be great. Right, so let's have a look at this code. Most of this code is commented out with these hash symbols. Anything after a hash is ignored by Python. So we've just got these lines here, the import statements. We've got 3 lines of code here, which is we're going to create a new window, we're going to put a label in the window, and we're going to link that label to the window. That's what those 3 lines do. And then if I look right at the very bottom of this code, there's a line that says tk.main loop. So if I scroll right down, there it is, tk.main loop. And what that is, that's the event loop that graphical user interface applications require. And so that just keeps running in the background. So if you don't have that line, you won't see anything. The program will just end before anything happens. So I'll go back up to the top. We don't need to see this pane here anymore, so I'm going to click on the project tab and hide that. And we don't really need to see this terminal down here, so we can see as much as we've got. Now I'm going to run this file. And so just see what your keystroke is here for the run command, and I'm going to do a slightly different one, which is just run the current file. This one is run ... which lets me run a different, set up some parameters for running, but I don't even need to do that. Okay. Yeah, so actually, if you're using Anaconda and you want to install pip, there's a conda install way of doing that. So you should always try that first, and if that doesn't work, then you use pip install. But when you do use pip install or conda install, you have to have the, well, pip install definitely needs the environment to be active first. Okay, so I'm going to use Control-Shift-R. I think on Windows it might be Control-Shift-F10. And there it is running, my first GUI app. So those 4 lines of code have created a window that I can move around. I can put text in it that I've done. I can even minimize it, and that's where that's gone. There it is. Bring it back. And it's even got some menus here. You won't get those menus on Windows. Okay, and then to quit the app, I can click on the red button for me. Okay, using 3.7, had to get rid of equals, yes. So I've used a few Python 3.8 commands in this example. You're obviously running the answers example because they're commented out in this one, so you won't have that problem yet. But I'll show you where they are. Yeah, so you'll see something like this. So this is a format string inside the curly braces, and there's an equals there. So if you delete that equals, then it'll work on Python 3.7. The reason what that equals does is it actually shows you the value of this expression, and it shows you the expression. So it saves you a lot of typing when you're writing up these format strings. But yeah, the problem is that they don't work on 3.7. So here, I'll just say remove the equal sign. So if you just delete those equal signs, you'll get the format string will print. It just won't get the descriptions of what it is that it's printing. You'll just get the values. All right. So that's task 2. If you get task 2 running, that's a big step to actually have. These are the first 2 tasks are the hardest tasks here, is how to get a graphical user interface program running. If you've got that running, then that's great. If you're still having problems, let me know. But if I don't hear anything, I'm just going to keep working on. All right, so the thing is here, change the text to be switchboard using label heading config text equals s. All right. So that's pretty easy. We set label heading to have text of my first GUI app, but now we want it to read switchboard. So we just say config, and using the config method on label heading, it looks just like the constructor, which was up here. We just put the parameters in the same way. Text equals switchboard. And so if I run that, here's the new window. Now you have to remember to quit it before you try running it again, otherwise it won't be able to run them both at the same time. So now say it's the word switchboard, and I can close that. And I'm going to hide this here. All right, now I've provided another solution here, which is all commented out. So if I select all of that code there, all the way down to task 4, and I do, for me, it's command slash, but if you want to see what it is here, see there's a menu item here in the code menu, comment with line comment, and here's the keyboard shortcut. So for me it's command slash, might be something different on Windows. So you see what it is, or you can just select that menu item and it will uncomment all the code. So this is the other way of setting the text for label heading. You can use the dictionary index format of assigning a value to a key. So label heading text equals switchboard. That's another way of doing it. And you can also do the same for justify. I didn't have it in there for some reason. Oh, probably because it was already justified to the left. I don't think you'll see any difference. All right, so that's if I run that. Okay, Control/ is the command for Windows. Thanks, Leo. So we've seen what it looks like with switchboard. Now we're going to add a button to our graphical user interface. So if we look down here, our button help grid is what we're going to call it as our variable name, and we're going to use a constructor for the button class in TK. So remember, TK is our tkinter library that we've imported. We've imported it tkinter as TK, so we don't have to type tkinter every time, we just have to type TK every time. And like a label, we have to set what the text is, but on a button we can also set a command, and the command is a function that must be previously defined that is what will run every time we click on this button. So it needs to be able to call this function without giving it any arguments. So we've defined a function up here, define click help grid, that's got no arguments, and what it does is it creates a new top level window with a title of help grid, and in it we've put in a label, and the label is just a bunch of text, and I've chosen the text to be this, which is the TK library. The label class has got a method called grid that we've called already, as we see here, label grid. So I thought I'd just have a look at what the help tells us about this class. And then we lay out the element. So we lay out the top level window on the label we say put it in. Now at the moment I'm using grid. I could have used pack with no arguments. They both behave pretty similarly. And label help knows what its master is, which in this case is top, and so it puts that label into the window that's stored in the variable top. So let's see what that looks like. Okay, here it is. It's a bit small to see, but hopefully it's clear enough, and if you're running it on your computer you should be able to see it there. So we've got our first label switchboard and our button help grid. Now when we click on help grid, it opens up another window, and that other window's got a bunch of text in it, which is all the help information, the doc string that we got from tk.label.grid. So you can see that we can specify a row number here, we can specify a column number, we can specify a column span, and it's for laying things out. So you'll see as we go on and lay out more buttons in our window here, just how they get laid out. But at the moment, it's just laying them out one after the other because we're not providing any arguments. None of this data, no padding, no row numbers, row spans, or sticky values. Now I can close that window by clicking on the red button, and in Windows, of course, it's the X in the title bar. Okay, are you having success in getting this to run? That would be good. And I can quit once again. Okay, so if you want to set the window size and the position, you use the geometry command, and we'll get onto geometry later on. And I'll show you how to do that. So for people who don't understand about where we got that help information from for the grid, I'll just run this in the Python console. So this is what we did. We import tkinter as tk, and no module named tkinter. Oh, this Python console, that's still running 2.7. I'm just going to restart that one. It's now running 3.9. And then I can do a help on tk.label.grid. And so you see I'm doing help with grid without parentheses, and it'll return the doc string for me, which is this information that we've grabbed using underscore underscore doc underscore underscore, and we've put that into our window. Okay, let me know if you want any more on help. Okay, so that's help. Okay, so task 4, add another button to see help on bind. So it's going to be pretty similar, so I might just do a bit of copy and paste. Help on bind. We'll say bind here. And we want a button to help on bind. So we're going to create a button. It's going to have the label on it. It's going to say help bind. And when we click on it, it's going to call a function bind, which is there. Now you see by default it tries to put the parentheses in. We don't want the parentheses. We're passing the function name, not calling the function. So if you put parentheses there, it'll try to call a function when we run this line. And then what it returns from that function is nothing, so it'll put nothing in as the command. So that's no good. We want the command to be run, we want this function to be run when the button is clicked. Okay. So we'll try running that. And you can see we've now got 2 buttons, help on grid and help on bind. And there's bind, there's a bit more to that, and we'll be looking at bind later, so then we've fortunately got the help there that we can read. Okay. Now how does this compare to the solution that I've provided here, commented? Yes, so I thought whenever you copy and paste code, you think there's the warning bells, is that you should be generalizing your code so that you can use the same set of code for in different situations. So what I've done here is I've written the same code that would work, and we just have to provide the name of the thing that we want help on, and it will create a button for that, and it'll have a function that can be used. So if we say we want to add button for help on pack, then that'll call this function here. Button help will be a dictionary, and the name will be, so name, which is pack in this case, button help pack, will be a button that is labeled help on pack. And I've used a lambda here to convert this function here, which takes 1 argument, into a function that takes 0 arguments, because we're providing, at the time of writing this lambda, we're providing the name. So that name is going to be pack, So we're going to click help by name pack. So every time we click on that, it'll call the function, which is unnamed. It's because Lambda are unnamed functions, but it'll call click help by name on name. And similarly, do the same again for config. And then it'll add them into the grid. The other thing that I've done is in our top level windows, I've created a close button. So the master is top, so the close button also shows in the top level window. It has text close, and what it does is it runs top.destroy, which is the way you close Windows. And it packs it in. So here we're using pack rather than grid into this window, and here we're using grid because we've been using grid already. So you can't change your layout manager once you've started using one. So this is going into our root window, so we've got to keep using grid on that one. And this one is using pack. It's just an example of how to use a different layout manager, although as up till now they're both doing the same thing. So let's see what that looks like. Here we go, help grid, bind, pack, config. And we can click on that. I can see I've changed the font as well. We've put a close button down here, so I can click on close, and same on help config. All right, so what I normally do here is I give you a task. We work through the simple solution that just does the task, and then I provide another solution which does more than really what the task asks. But by doing that, you learn a few extra things about Python or about what we're trying to do. Okay, add a button which creates a window showing the current time. Okay, well, I like copying and pasting. So let's do that, because I know that worked. So let's call it time. Oh, it's not even help. Click time now. And it's going to, let's call it time now is the label on the title bar of the window, and it's going, the text is going to be date time dot date time dot now, formatted string format time, and we'll just do percent D, oh no, time, percent H, percent M, percent S, justify, don't really need justify, label, and now I'm going to rename this, so let's call it label time. And this is one of the reasons I really love using IDEs, is because they've got tools such as refactoring. So I can use Shift F6, which I don't know if it's one of the, it's not one of the ones there, but anyway, for me, Shift F6 brings up, now lets me edit this name, which I'll call label time, and then because label time is just a local variable in this function, everywhere that label help was has now been renamed to label time. So that made it easier. And we'll call this button here. Now I can't really rename this one the same way because this is in the global scope, and if I rename it here, it'll rename it in the other area where I don't want it to be renamed, but it's going to be called time now. Click time now, no parentheses. Okay, and that's just, see, I didn't stop it before. I'll try doing stop and rerun, see if that works. There we go, it did work. So there's time now. I can click on that and it tells me that the current time is 18:09:31 and quit. Okay, so let's have a look at the solution. And what this does is a little bit more complicated. This provides us with an updating clock. So let's run it and see what it looks like. So we've got time clock. I click on that. I get a much bigger font, so that's nice. I've got the time showing. I had a countdown timer there going down 10 seconds. And this time just keeps updating every second. I'm also showing microseconds here, and that's just for interest. You don't really need to see that on a clock. So let's have a look at how that's been implemented. See if there are any questions. Fonts. Yeah, so you can use fonts that are installed on your computer. So I've used the Courier font here. So when I set the label, there's a named parameter, font equals, and you can say the font name and the size. So let's see if it tells, no, it's not really telling you much there about what you can provide. But that's how you provide a font, the font name and the font size. Right, so here I've set the format for setting the time. So it's hours, minutes, seconds as before, and %f gives us microseconds. And I've created this function inside the click time clock function. So by being inside, it's got access to the format string. And what that does is it sets the text of label time. So it's also got access to label time. And it's also got access to the countdown IV count. So IV is for int_var countdown. And it just reduces that by 1 until it gets to 0, and then it'll stay on 0. So what we do, we create the window with a label. We put the time in there. In fact, I've just put in some dummy time saying start me. We pack that into our top level window. Then we create a frame. So a frame is like a window. So you can put things into a frame, and then you can put the frame into the window. So if you've got a few elements that you want to move around all at the same time, you put them into the same frame. So for example, I wanted the label for countdown and the entry for countdown to be in the same frame. So I created a frame, and then I packed inside that frame, and then the frame I packed inside the window. So this is an area where the layout, you can use one layout manager for frame and a different layout manager for the window that it's going into. Okay, so right, so I've chosen Courier, and I'm on a Mac. Maybe on Windows it doesn't have Courier, so you could try Courier New, or just one of the fonts that you've got in Windows or Linux. It looks like you're on Windows. Use one of the fonts that you've got on your system. Okay. All right, so once I've created the whole thing, then I call update time clock. So the first time update time clock gets called, it sets the time into the label. So it sets the text of the label time to the value now, and it formats it. And then it calculates, the next thing it does is it counts down. But then it calculates how long it's going to be until the seconds change. So what I've done is I've looked at how many microseconds there are, divided them by 1,000, integer division, subtracted that from 1,000, and that'll tell me when the clock needs to be updated. And so I'm saying to label time, after that many milliseconds, run update time clock again. So it just calls itself and runs it again, and then it waits. Now was set here. We're doing the calculation there. So it's obviously taken a bit of time to get from that line down to that line, and that amount of time you'll see in the number of microseconds that are now showing on the clock for when the next now is called. And that's why, so Leo got 497 on his, he got 497 on his, so obviously it took 497 microseconds to get from there to this calculation. Well, yeah, to do the calculation for the next time. So I'll run this again now that we understand what's going on, and yeah, my font's looking quite good. So my computer's a bit slower than Leo's, so mine's taking 1,500 seconds to run those 3 lines, so about 3 times as much time. Okay, so now we're getting on to task 6. Create a window which accepts a string into the string var SV service name, and it's got a label of service name. All right, so we have to use this SV service name. I'll just hide that. Now, this is how we did it for an int var. We're now going to use a string var. So int vars return numbers, string vars return strings or text. So let's, and it's going to be called service name. So let's do our copying and pasting. Okay, so we're not doing any updates on this one, so we don't need any update happening. We don't have any formats, so it's going to be click service name. We're going to create, in fact, we don't even need any of this. We'll just say our label for the service name is going to be service name. And that can just be straight. We don't need a frame. We'll just go straight into top with that. We're going to have a string variable for service name, which has already been defined, so we don't need that. We'll have an entry. So an entry is where you can actually type in text. So we could have typed into the countdown as well, but we didn't. Service name. Okay, Peter's got a nice looking clock, so that looks like the time now button. So that's looking pretty good. I'll just have a look at that. There's Peter's one. Yeah, so functions in a function. So you can see, looking at functions inside a function, you indent even further. So you know that you indent once to when you start a function, and then if you put a function inside that, then it's got access to all the local variables of this function. And we needed format, we needed label time. So that's the advantage of having this function in the function. Now, if I define that up here on the outer level, it wouldn't have those values. So I would need to pass them in as parameters, but then I couldn't call them over here in the after method, because that needs a function that has no parameters. You could call it a nested function, or you could call it an embedded function. Peter's got a nice picture of his clock with the microseconds. So let me know what you think of these graphical user apps. Like, does it feel like a real graphical user app, or are you noticing something different about it than your normal apps that you run on your computer? Oh, good. Leonardo's never seen this in other languages, just how to make a GUI app. But most languages will have a way of doing a GUI app. But it's quite a lot of work. In the early days when we were writing GUI apps, we had to write the whole event loop ourselves. So it's just fantastic that all we need to do is that one line right at the bottom of the code, which is main loop, tk.main loop, and it runs the whole event loop itself, and we can just define it by, in this case, where we're just defining commands against buttons to run it, and against that after. But soon I'll show you how to actually do events as well. Okay, where were we? Click service name. Okay, so we've creating an, we don't need that label, we don't need any of that. Right, the font name could be case sensitive as well, so try different case. I haven't actually tried running this on Linux, so I can't say that I've had success. I haven't had failure, but I haven't had success either. I don't need to pack that, and I don't need to start the clock. Right, so in the grid here, I didn't point this out before, but we started using row and column numbers. So the time clock went into row 2, column 1. So we'll go row 3 for this one, column 1. Okay, that's the service name. And that's all we're doing. All right, so let's try running this. So now we've got our button for service name. I'll click on that, and that brings up a place where I can enter code. So let's just call it new. Press enter, I could close that. And if I run it again, it's remembered. You see it's using the same string variable, so it's remembered that value. And I could do something with that. I could save it into a file or a config file or something like that. So let's delete that. Okay, so our next, what do we got? So that's task 6. So we've satisfied task 6. So let's have a look at the solution here that does obviously a bit more. And I'll just uncomment that. Right, so rather than just service name, I'm going to create a couple of string variables. I'm going to have one called username, and I'm going to have one called password. And the username, I'm going to default to the current user, so that's me. So it's going to look at my operating system and find out what the current username is, and it's got a few ways of doing that. And then I've got to have a password, and the password I'm going to leave blank for now, because what I'm doing is I'm asking someone to supply the password, so I don't want to hard code any passwords into here. And that password is going to be used for something like connecting to an email server or connecting to a database. Right, and this time, rather than have a button on my switchboard window, I'm going to create a menu item. And so I'm going to call the menu Authentication. So let's see, down here is where I create the menu. So window, remember, is our root window. And so I'm going to create a menu that links to that root window. So when the root window closes, the whole application closes. And that gives me the menu bar. Then I'm going to create an edit menu that's going to be part of the menu bar. That edit menu is going to have a command in it called Authentication in the menu, and when that gets selected, it's going to run the command menu Authentication. I'm going to add that edit menu to my menu bar using add cascade. So remember, menu bar is really just the menus across the top, and the edit menu is now going to be one of those menus, and these commands are going to be in that menu, but then I could do submenus from that using the same add cascade technique. And then that window I can config in my new menu bar can show that. All right, so this is going to call menu authentication, which creates a whole new window with the title Authentication. And here's a geometry. This is what geometry looks like. It'll be width times height plus top left X plus top left Y. So I'm not going to set the width and height, so I'm just providing plus top left X and plus top left Y. So that'll give me a location where this window is going to display. And it's going to have a label in there that says enter credentials, and I put these all in a frame. So it's just text variables. This one here, this entry is interesting because rather than showing the letters, I've put a symbol that I'm going to show instead, which is just a dot. So if someone types in a password, then people looking over the shoulder aren't going to see what it is. And then I'm going to have a button in there to save the password, and that's going to call click save password. And this is where I use Keyring. Keyring is going to then set the password. It uses the service name and the username, and so there are two things that it needs, and then it puts in the password. And what it does is it looks at what you've got on your operating system as a good place to save passwords. So if you're on Windows, it'll be looking at Credential Manager. If you're on macOS, it'll be looking at Keychain. And if you're on Linux, I've tested this on Linux. Actually, I have tested this on Linux, and it used GNOME, the GNOME Keyring Keychain. I think it's just called GNOME Passwords or something like that. All right, so let's try that and see how it goes. All right, so if you look at the menus up here, now I've got an edit menu, and in that menu I've got authentication. The Mac's got a couple of default things that have added in automatically, but if I click on authentication, it's got my service name from before, it's got my username, Pythonator, so I'm logged into this computer as Pythonator, and now I'm going to type in my secret password, which is just secret, and I'll click save on that, and you see down here I've logged it out. You shouldn't really ever log passwords, but in this case, because it's for training, we need to see what's actually happening. So the username.get is Pythonator. The password from what I typed was secret, and then it has, this is now pulling out the password from the keyring using the service name and the username, and the password it got back out was secret. So that worked. And now if I look in my keychain, so I'm just going and looking at my Mac keychain, which is in Utilities, I think. Keychain Access. Okay, so here's my keychain access. In the login keychain, my passwords. Just got a bunch of things there, but there's the one we've just created, BPAML, Beginners Python and Machine Learning tkinter Demo. And if I open that up and say show password, it's just going to require my, just move that off the screen. There we go, show password is secret. So it's stored in my Mac keychain, the secret password. So I'm not saving it in plain text anywhere on my computer, apart from the log files at the moment, but you know not to do that. And so it's a reasonably safe way. So it means that if the person can log in to this user, they can get hold of those passwords that have gone in with this user into the login keychain. But if someone's got in this far, then you know that you've got problems already. So it's no more secure than your user account on your computer. But it is a lot more secure than a plain text or even an encrypted password somewhere else. Because if you've got an encrypted password saved with the program, then your program's got to decrypt it itself. Then the program's got to have all the decryption techniques showing in the program, so someone can just read the program to work out how to decrypt the passwords. Okay, how are we going? I'll just see if there's any comments. Nothing there. And nothing on YouTube. Okay, very good. Okay, task 7, add a menu item which prints the password from the keyring. Okay, well that should be pretty simple. So let's, it'll be on the edit menu. So even though the edit menu has been added to the window menu bar, we can still make changes to it. We'll just call it print password, and we'll create a function here and so that's just going to print to the console, and it's going to use Keyring to get the password, and it's going to use the service name, and it's going to use the username. So you can, if you want to save more than one password, you can go in and change the username or the service name even, and save more passwords into keychain access that way. We added a command, I called it log password, to differentiate from print password. So you can also, on your menu, and this underline, that works on Windows, I don't think it works on Mac, but you can say which letter in the menu item do you want underlined, so I would underline the L, and you can say which shortcut you want to use. So I want to use Control L as my shortcut as the accelerator, and that'll show it on the menu, but it doesn't actually set what the shortcut key is. I have to then set an event by binding. If someone types in Control L, then it runs menu long password. So they can either select the menu item, menu log password, or they can type Control L and you'll get menu log password. Now you can see here I've used window bind all. I could have used window bind, but that would have meant that Control L would only have worked if the window was the currently active window, the root window, but not if any other window is active. But usually for menu items you want them to work at all times. So I said bind all means at any time Control L is pressed, then it should work. So let's have a look at see how that runs. Log password, you can see Control L is now showing in the menu, and if I now type Control L, I get a log message coming down here. Even if I've got another window active at the time, and I do Control L, it logs it again, and it's bringing it out secret from the keychain, just like it should. One thing I did notice, I didn't have there's no underlining on Mac, but on Windows you should see the L being underlined. So that number there, 0, is the index in the string that you want underlined. So it can only be a single character, and you just have a single integer there to say which one to be underlined. When I set the accelerator, but I didn't do the bind, I could do Control L and the menu would flash, but it wouldn't run, it wouldn't call menu log password. So you need to do the bind to do menu log password. Now how to find out what to name these things here and how Control L binds that key, you can have a read through help bind, which we've got here, and you can see it's less than sign, then modifier, modifier, type, detail, and then greater than sign. And so we're using a modifier control. So modifier is one of control, mod 2, m, all of these modifiers. Even button 1, so button 1 is the first button on your mouse. Button 2 will be the right button on your mouse. Button 3 will be the middle button on your mouse. There's even got button 4, button 5. And then, the type, let's see, so that's them. So type is one of activate, enter, map, button press. So you can catch a button press, you can get just a button, and these button release, focus in, these are the sorts of events that you can capture, and then some detail for it. Okay. All right, so we're making good progress here. Task 8 is create a window with a canvas and draw based on mouse down events. Now that's a pretty hard task. That's more a demo than a task. So I've got the solution here. So let's just uncomment the solution and see how it works. Okay, so we create a button that opens up that calls click button draw, and we put the button on the main window. So nothing special there. Now in click button draw, we've defined a starting point. Oh yeah, so start is really where your previous position was. If the mouse gets clicked down, which we're defining down here, if button 1, so the left mouse button is clicked, then we want to run mouse down, which means store the values of start X and start Y and make them equal to the event.x and event.y. So it's where the mouse, we're now doing events, and because we're using events, we can have functions that have a single parameter, which is the event. We're binding to events. So event.x and event.y tell you where the button was pressed. Okay, so Leo's saying tkinter is using just the core fonts in Linux. It'll have to be patched to use other fonts. Okay, that's interesting. All right, and now the other thing we're looking for is if button 1 has gone through a motion, which is that's saying you're dragging with the mouse with the button 1 pressed, then it gets another event, which is the new x and y coordinates. And what we're going to do is on our canvas, we're going to create a line from the previous place to the new place, and we're going to then store the previous x and y coordinates. So when we create our window, it's a top level window once again. We're going to set a grey background. We're going to set the geometry, so this time we are going to set the width and the height. We're going to put the, we're going to create a canvas in it, and we're going to place it. So the relative x and relative y says it's going to be placed in the middle of the canvas area, is going to be placed in the middle of its top level window, and it's going to be anchored to the center of it. So that means we're going to see it in the center. So let's have a look at what that looks like. Stop and rerun, we'll try that. We've got a drawing button here now. Okay, so here's our window, and I can just drag the mouse in there, and when I resize it, the canvas, which is the grey area, that dark grey area, is always stays in the center. So that was the advantage of using place rather than grid or pack. Close it, click again, I get a new one. So beginners, Python, and machine learning. There we go. So I hope this all worked on all of your computers. There's quite a lot. I've really tried to explain concepts rather than tell you how every single bit works. And so now you can go and look up the different parts and read about it, and you'll be able to understand what they're saying. I've put in some reference points here. So here's the main docs on how to use tkinter. So tkinter module. So that explains it. Now there's different ways of running it. So this is, they're using it as a in an object-oriented fashion. And that's probably the recommended way of doing it. I haven't done that because that just added another level of complexity. But if you can understand what I've done now, then you should be able to adapt it into this object-oriented way of setting up a program. It explains where it all came from. So there was a scripting language called TK, and so that's really what they're doing, is using TK to create this graphical user interface. So Python is actually taking your commands and converting them into a script for TK to run, and then TK is creating all the widgets, which is why sometimes it seems a bit backwards the way you do things. Like when you're adding a label into a window, I would have thought you would take the window and pack in the label, but you actually take the label and pack it into its window. It just seems a backward way of doing it, but there's probably a good reason for it. So what else did I add? There's a reasonable tutorial at Real Python on how to use tkinter, and there's also the Keyring project, which is a surprisingly simple library which solves the passwords problem, which is a very difficult problem. Okay, Peter says he nearly got there. Which bit didn't he get? Um, so that's all from me today. I'll stick around for a couple of bit to, if you've got any more questions that you want to ask. Next week is first week of the month. So on the first week of the month we do an absolute beginners session. I'll be doing it on Turtle graphics. So once again, it's a bit similar to tkinter. So you need tkinter to be able to run on your computer to be able to do Turtle graphics. But Turtle graphics are a bit easier than all this stuff that we've been doing. And they're a good way of learning the basics of Python. Rather than Turtle graphics, you're probably not going to use a lot, but it's a good way of seeing how a Python program runs, because you can see the output in Turtle graphics and see how it's what it looks like as the program is running, so you get that idea of program flow. Okay, so Peter's got a menu authentication not defined. So that's menu authentication is the name of the function that we're trying to call. So you need a function here called menu authentication. If you don't have that, then you'll get a problem down here trying to call it. So this is part of the code that was commented, and you just have to uncomment it. It's part of my solution 6, so you just need to make sure that line is uncommented. Will we cover post-turtles? What are we talking about there? So in the so remember, the next week is supposed to be for absolute beginners. So we'll be doing Turtle graphics, just the really basic part of Turtle graphics, and just showing really how to create functions, how to do arithmetic expressions in Python, how to use variables and a few different data types. Maybe lists and dicts, we might get as far as that. Google a post-turtle. Okay. All right. Well, thanks for watching. I hope it was informative, and I hope you all got it running. See you next week.